Hello guys, welcome to the video. This is yet another video on indexes in SQL Server. Today we will be covering included columns and what value they add to the queries coming in from the application. To start off with, we'll just create a small setup and then I'll walk you through some execution plans. So let's get started. We are using AdventureWork 2022 database. I am setting up enabling these configurations. I am creating a test table called SQL curve, and then we will be inserting some values into it. So now we have the required tables called SQL curve. Currently, it doesn't have any indexes, neither clustered or non-clustered. So to discuss further around uh, included columns, so let's actually add one more column to this particular table, which is slightly bigger in size. So it is nvarchar 1000. So I have added this column, and the default value is a in it. So further, if we move, so let's actually come back to our SQL curve table now, and let's try to select something between the range of 40,000 to 54,000. So if we'll see, uh, we got the three columns. Uh, Let me start the actual execution plan also. So there were around 1700 logical reads in execution plan because there is no table cluster. Sorry, there is no cluster index or non-cluster index. So it ended up doing a table scan, and it has returned us around 51,000 rows. Now, if I create a cluster index on it, that is, let's say, uh, primary key which is clustered, and I create it on sales order ID. It is on the primary schema. This is the name of the index. Let me create this. So now we do have a cluster index. The cluster index doesn't need any included columns because the leaf level of the cluster index includes all the columns. So the feature of included columns is only applicable to non-cluster index. And for cluster index, just to revise our previous videos, all the leaf level of cluster index actually have uh, all the rows or all the columns, you can say. So there is no if we end up doing a cluster index scan, we are anyways reading all the leaf level pages. So that's why included columns are not applicable to cluster index, because by design they are actually including all the columns. So further moving on, if I actually, so now if you for take a look at the sales order detail, the query, this particular query is actually not based on sales order detail ID, it is on sales order ID. So if I actually have a where clause which is not the column on which we created the cluster index, we will still end up doing a cluster index scan. Because we are actually we can't have a cluster index seek because we are not passing the column on which the cluster index is created. So if you take a look over here, the cluster index scan, we had this. I assume my recorder is not actually recording the pop-up dialog box that is coming up. I'll fix it in upcoming videos. So over here it is actually giving us the optimizer is giving us a recommendation about this covering index. If you see over here, the include column is mentioned over here. So, and also if we just take a look at the logical reads, that they were close to 40,000. So this is about passing in a where clause which has a column which is not based on the cluster index. Now let's actually try to run a query which does has the column on which our cluster index is there. Over here we had 40,000 IOPS, and because actually the rows won't match because the values are not evenly spread. So now I am passing a where clause where the cluster index is created on. So let's have a look at this. So over here we get a cluster index seek because we pass the right predicate. And if we take a look at this, there's a change in the total number of logical reads. We were much higher than 3000. Uh, so, but the rows are slightly less because we are not passing the right range of rows. But this was to demonstrate that if we pass the right cluster index column, we would actually end up incurring a cluster index seek, which is much faster and optimized compared to a cluster index scan. So now moving on to our key aspect of the video is the covering index. If I actually create the non-cluster index uh, with all the columns. Remember we added one more column to the table which was very big in size. So if I try to create this particular non-cluster index, mostly we'll get an error because the size of the overall size of all these columns put together is actually exceeding this length, which is applicable for a maximum. So in I'm on 2000, this is 2022, and the maximum length could be 1700 bytes. But all these column put together are actually, because this itself is 1000 and the other columns are also slightly bigger, so we actually end up hitting this particular limit. So the one reason we would need a cluster covering index in our non-cluster index is to avoid this scenario in which our key columns of the non-cluster index actually exceed a particular limit. So the included column could be leveraged in this scenario. So if I create the same index over here, we have kept the non-cluster index key as sales order ID, but product ID and column ID are actually part of the included columns. So if we create this, and our base query would actually now be sufficient to be served from our non-cluster index only. We don't have to actually jump across to the base table or the cluster index. So there we would actually end up improving our overall performance. So these are the same set of columns that are part of our included columns in our non-cluster index. And if we run this query, so we are from 50,000, we are down to 7,000 logical reads, and also we are ending up incurring a index seek, which is optimized as compared to uh, cluster index scan. Now, if we actually try to force the leveraging of an index, now in first query we are actually forcing the cluster primary key cluster index to be used for this particular where clause, and in the second case we are actually forcing the non-cluster index that we created, which had the covering columns for product ID and column one. So let's actually run both these queries together and see whether we are able to see any differences. So in the first query, if you see, we are actually incurring a logical reads of 40,000, whereas in the second query, we are actually only doing a logical reads of 7,000 something. And in execution plan, the query which is actually doing a scan or a cluster index scan is actually contributing to 84% of the overall execution plan, whereas the optimized non-cluster index with covering columns actually is only contributing to 16% of the overall time taken. So I hope this is helpful. So the covering index is just to reiterate, a covering index is applicable to non-cluster index. This is where we want to actually ensure we don't actually incur. Let me actually disable this particular non-cluster index and show you again what we actually wanted to avoid. So this is going to cluster index seek. So I was actually trying to cover this particular scenario. Now I have created, uh, I've reduced actually the column one, which was causing the overall creation to fail. So let me delete this once. So I have deleted. So now what I'm doing is I'm creating a non-clustered index which is on sales order ID and product ID on primary, and this is I'm calling it a cover. So this is a non-clustered index without included columns. So this is created now. So if I actually force the leveraging of this particular covering index, what we would actually end up doing is we would be hitting our non-cluster index first to get sales order ID and product ID, but the column one is not there. It is on the base table on the cluster index. So we would see something like this. The cluster index seek will be there from where we'll get the first two columns, but key lookup has to happen on the base table or the cluster index to get the column one, and then for each row that is written from the index seek in non-cluster, it has to actually go through all the rows in the cluster index. If we actually see the number of logical reads that has happened, this is beyond 50,000. This has come close to 94,000 now. So this is the reason we actually would actually prefer covering index versus actually incurring a key lookup on the base table, because it would have to go through some nested loop or some other kind of inner join, which would actually increase the overall physical rates. For a bigger table, this could be drastically causing a lot of performance issues. So let me just close the video. Let me delete this again, and create the covering index again, or the included column. So this is the column that we were talking about, and I'll take this particular force this particular usage of this non-cluster index which has the covering column. Now if we go to our we are down to 7,000 something for logical reads, and if we go to the physical plan, we don't get that row lookup or RID lookup on the base table, because our query is actually served from our non-clustered index which has covering columns. So that was the video, guys. Thanks for watching this far. I'll continue adding some more videos to the index series. Also, do note that actually I'm planning to start a ChatGPT playlist. So I'll be covering basics around ChatGPT, and also how DBAs and other IT professionals and can actually leverage different offerings of ChatGPT, or maybe the GPT that we have from Google, that's Bart. And also there are some extensions which can actually we can actually hook up into our browsers, which can actually have summarizations or auto suggestions or auto code completions for the queries that we are actually searching in Bing or like Google itself. So thanks for your time, guys. Do consider subscribing and liking this video. See you in the next video. Thank you.